Okay, I'm just going to go through a few quick review examples. So if we have something like 0.12x plus 0.10 is greater than or equal to 0.02x. So there's a lot going on, all within this one inequality. I've chosen, like, you know how it goes. It starts off sort of easy and then it builds up and gets harder. So I've chosen one that has quite a bit of stuff going on in it, since this is review. So what's the part of this that looks a little bit challenging? What's the part that's making this equation or inequality a little bit tough? The decimals. Can we wipe them all out in one shot? What's a smart way for us to do that? Good. Let's take this and multiply the whole thing by 100. And again, we're reviewing, but I'll just really quickly run through it. Because when we look at this, we think, okay, I need to move the decimal over twice. Same with here. Same with here. If there was one of them where I needed to move it over 3 times, then I would multiply by 1,000. But since it's only twice, 100 is great. So you tell me, what do we get when we multiply this by 100? This becomes 12x. Everybody good with that? Then we go back and distribute it to the second term here. What does this term now become after I multiply it by 100? Yes, thank you, Tully. So plus 10. This sign stays the same because we haven't multiplied or divided by anything yet. And then I go back to the 100 and I distribute it here as well. And so what do I get? What does this become here? 2x. Everybody good with that? Look at how much nicer this is to work with than the one with all the decimals, right? So now this is looking a lot like things that we've already seen. We have some options for our next move, and I'm not going to tell you or guide you. You decide. What would you like to do? What do you think would be easiest? Lucas?
Well, you can either move the 2x to the left and then move the 10 to the right.
Yeah, what would you rather do? Doesn't matter.
2x to the left.
Okay, so we do minus 2x. Everybody good with that?
Yes.
We're going to do that on both sides. So we end up with, what's 12x minus 2x? We get 10x plus 10, and then if we got rid of this, what are we left with on the right side? Nothing, so just 0, right? And then we want to get the x by itself, so what should I do? Take away 10 on both sides. Everybody good with that? And so that would be gone, which is why we did it. And so we would get 10x is greater than or equal to negative 10. And what's my last move? Divide both sides by 10. And when I do divide both sides by 10, my x value is greater than or equal to negative 10 divided by 10? Negative 1. Everybody good with that? And if we wanted to draw that out on a number line, just because it's been a while since I've seen you, I want to check to see you still remember this. Do I color in the circle at negative 1 if this is what I'm getting? If x is greater than or equal to... I do color it in, thank you, because of the fact that it says greater than or equal to. So because it has this little line underneath, I color it. And then do I draw my arrow to the left or to the right? To the right, thank you. So x is greater than or equal to negative 1. Greater than or equal to would be talking about like 0, 1, 2, etc., right? So that was pretty quick, but we have done it before. So are we okay with that recap of how this works? Okay, let's do another one that has something slightly different. Let's say we have 7 is greater than negative 1 over 2x plus 3. We want to solve or isolate x? What is the smartest or easiest first move in working with this? Yeah.
I'll take the fractions.
We could, but we want to get x by itself. So in this case, we wouldn't, that's not going to help us because we'll end up having to do more work to then get rid of it after. Yeah, we can just subtract 3 on both sides. Everybody good with that so far? So the sign, well, does the sign change? No, we're subtracting 3, so the sign's going to stay the same. On the left here, 7 minus 3 gives us 4. This would actually be gone. That's the reason we did it. So we have negative a half x. Let's do this step by step. So I don't want to deal with the whole fraction all at once. I want to get rid of the 2 here. What's the easiest way for us to get rid of 2? What's the opposite of what's happening here? Yeah, so we want to multiply. This is dividing. We want to multiply by 2 on both sides. Everybody good with that so far? 4 times 2 is 8, which is greater than, what does that leave me with here if I had a 2 there and there? It's just negative x. Everybody good with that so far? So I had negative 1/2 x and I multiplied that by 2. So this 2 down here and this 2 here, they would cancel each other out. Because 2 divided by 2 is just 1, so it's actually gone.
So eventually you would do the same thing as what I mentioned at the start, but we should do it after.
Yeah. And then if we want the x by itself, what's my last thing I need to do here? I don't want negative x, I want x. How do I get rid of the negative? Divide both sides by negative. Oh, I didn't want that, I want pink. Divide this by negative 1. So that would then be gone. What happens to the sign when I do that? If this flips, so x is actually greater than, what does this become? 8 divided by negative 1? That's just negative 8. Everybody good with that? And if we wanted to graph that out, let's say negative 8 on my number line, do I color in the negative 8? The circle? I don't color it in, and if x is greater than that, do I go to the left or the right? We go to the right, which I made pretty obvious by drawing it larger to the right, but there you go. That's basically what it would look like. So far, so good? Let's do one more example with a whole bunch of things going on. 3x plus 2, all divided by 2, minus x plus 1, all divided by 3, and the whole thing is equal to x. We want to solve. What is the first move to help us to be able to solve this? It's looking pretty messy right now. Simplify, yeah, how? What's the difficult part about this? The fractions. Can we wipe them out? How would we wipe them both out? What would do that just in one shot? We want to multiply the whole thing by what number? 6 is a great choice. Everybody get the reason we chose 6? Yeah, so we look at both denominators and we want to find a number that they both will fit into, right? Or the LCM. So when I want to multiply this part out, we want to simplify. I could do 6 times 3x and 6 times 2, but then I'll have to divide them both by 2 separately. What's a quicker way to just deal with it right off the bat?
Do 6 divided by 2 and multiply the top by that.
Good. We could say 2 goes into 6 how many times? 3 times, so I'm left with 3 times 3x plus 2. Everybody see that simplifying trick we're using? So then we want to do the same thing over here, minus, and how many times does 3 go into 6? So this 3 goes into 6 twice. So we would have 2 times x plus 1. Everybody see how we got that? Questions? Or is it making sense so far? We're okay with that? And then we have to go back to the 6 and make sure we also distribute it here. So what is the whole thing equal to? It's going to be 6x over here, right? Because if we look at the x, there's no number there to divide by or to simplify. It's just 6 times that. And so this still isn't that nice, but it's starting to look a bit better. We can remember this trick. We're going to live in denial, pretend that never happened. How do we just deal with this part? Yeah, 9x when we multiply these, and then when we multiply this, it'd be plus 6. So far we're good with that? And then we only live in denial temporarily and bring back the thing that was scaring us, which is this. And this one's a little bit tricky too. We have to keep the sign to the left of the number with that number. So we're doing this times this, minus 2x, good, and then minus 2. We're good with that? Want to ask me anything? It's a lot, and we're going pretty quickly. Arden?
I think you just explained this, but why is it that it goes from plus 1 or plus 2 to negative 2?
Oh, because this always, when we're looking at a number like this, the sign to the left of it, it's like they're stuck together. And so we're not just doing 2 times x and 2 times 1, we're doing minus 2 times x and minus 2 times 1. Good question. Good? And then the whole thing was equal to 6x, but we were just temporarily ignoring it. So do you see that this one up here is the same thing as this one, but the bottom one's looking a little bit nicer to work with? I mean, it's still not that nice. There's a lot of stuff happening. Again, we can ignore the stuff on the right for a minute. Even just on the left, let's clean things up as much as we can. So which are the like terms here? Yeah, what's 9x minus 2x? We get 7x. Everybody good with that? And then we have 6 minus 2, which is plus 4. Good. And then the whole thing is equal to 6x, which we got from over here. So do you see that step-by-step approach we're taking? Hopefully to make it a little bit easier or more manageable. What should I do next? Sure, let's minus 6x on both sides. And the reason we did that is so that this would be gone. What does it leave there if we've subtracted everything away? It leaves a 0. What's 7x minus 6x? That's just 1x, yeah, plus 4. And what do I do next? We subtract 4 on both sides, so that's gone. So x is equal to negative 4 after all of that hard work. And that